everyone, and welcome to our webinar. As well as writing for Farmers Weekly, I farm with my husband and son in Pembrokeshire. My name is Debbie James. For the next hour or so, we will explore everything you need to know about how to use integrated pest management, or IPM as we know it, to protect your oilseed rape crops. We will speak to experts to understand how a hybrid oilseed rape characteristic has been bred by Limagrain to be resilient to cabbage stem flea beetle, and how genetic traits and characteristics could make the difference between a crop succeeding or failing. There will be tips on how you can optimize pest management, boost yields, and future-proof your crops. You, as our audience members, can ask a question at any time. Just type them into the box at the foot of your screen, and I'll direct them to our panel. I will now hand you over to our speakers and allow them to introduce themselves, starting with Florentina, please.
Hi everyone, I'm Florentina Petrescu and I'm oilseed rape product manager for Limagrain UK and Ireland.
And Patricia?
Hi everyone, my name is Patricia Ortega Ramos. I'm an agroecologist working at Rothamsted Research. I've been there for 8 years doing my PhD and then as a research scientist working mainly on integrated pest management for oilseed rape.
And last but not least, Ben.
Hi there, Ben Abel, Head of Agronomy, Dighton Farming. Dighton Farming farms over 12,000 hectares across Lincolnshire, Oxfordshire and Gloucestershire, growing arable crops, root crops, AD crops, as well as livestock. So my day job is running the agronomy team in-house, so responsible for what we're going to grow, how we're going to grow it, and budgeting and taking that through with a direct cost for the business.
Thank you all. We'll now hear some more from Florentina and Patricia.
Here we are. Well, hello again. Thanks a lot for inviting me to speak here today. I'm going to do like an overview of what we do at Rothamsted Research regarding the integrated pest management in oilseed rape. So, yeah. So to start with, let's do just like a quick reminder of how many insect threats oilseed rape has. So you can see in the pictures from starting in the year from cabbage stem flea beetle in autumn, our big pest, and then going through the different types, species of aphids into pollen beetle, rape stem weevils, and brassica pot midge. So there's a lot of variety, and each of these pests attacks the oilseed rape in different stages. But fortunately, we have a really resilient crop that stands all these pests and still stands most of the time. So for many years, we've been controlling these pests using neonicotinoids, as we all know, but these were banned a few years ago now. And now the only other alternative is pyrethroids. But unfortunately, most of the pests that I've talked about are now resistant to it. So farmers are left with no chemical options, really. This has got a really bad effect on the amount of oilseed rape grown in the UK. So as you can see in the graph, it's been massively declining since the neonicotinoid ban. Although in the last couple of years, we see a tendency of it growing up, but in general, so we suffer a 46% decrease in the area of oilseed rape grown in the UK since 2013, and it was an overall of 12% in the whole of Europe. So it's clear that we need an alternative way of growing this crop and managing these pests, and that's what we are talking about today, about integrated pest management. So just to introduce this term, So integrated pest management isn't a single tactic, it's more like a toolbox, a catalog of strategies. So it starts at the bottom of that pyramid with prevention, like creating field environments that reduces pest populations and increases natural enemies, or using cultural control methods like floral varieties that we are going to talk about today, reduce tillage, anything that can help reducing pests. Then it comes the monitoring. So we need to know what's the pest pressure in our crop and compare it with the economic thresholds, see if control measure is needed. And finally, prioritizing target interventions like biocontrol, and last resource, trying to use selective insecticides, if any. So our group at Rothamsted is working on almost any single step on IPM. So I'm going to start with the habitat diversification, trap crops. So as you may know, trap crops are plants that are more attractive than the main crop and are used to divert the pest pressure away from the crop. So you can see in the image, back in 2005, we did this field trial where we put borders of turnip rape that are much more attractive for cabbage and flea beetle in this case than the actual oilseed rape. And we had really good results where flea beetles stayed mainly on this turnip rape, and the number of adult damage and larval damage was reduced. And then we kind of replicated this a few years ago with Duncan Coston, which is now working at ADAS. And we did exactly the same, replicated the turnip rape borders and found similar effects. So it really works at attracting cabbage and flea beetle away from the cash crop. Another alternative that we try is companion planting and straw mulch, in this case by Gaetan. And we did 4 field trials here in the UK and Germany, and using different companion plants and the addition of straw mulch. And we saw how it affected cabbage and flea beetle feeding and larval infestation. And we found that combinations of oilseed rape with cereals, in this case wheat and oats, as companion plants, or even the straw mulch, show a strong reduction in adult feeding. We also saw a protective effect of legumes, in this case clover, against the adult feeding. And we saw some larval differences between treatments, but those were not consistent between years and trials. So although there is something, we couldn't really see a significant difference over time. And our new project now on habitat diversification is looking at the differences between intercropping, undersowing, and floral margins. So in this picture, you can see we are focusing on cabbage and flea beetle and aphids. So in case of cabbage and flea beetle, we want to see how these different habitat diversification practices affect pest populations, but also natural enemies, how these floral margins can act as places for them to find refuge or to feed, and increase their populations in the fields, affecting the populations of the pest. But these flower margins and other crops that we can plant can also have a negative effect, acting as virus reservoirs, and therefore transmitting more viruses into our cash crop. So we're looking at the trade-offs between these management practices. Then another project that we're working on is this push-pull strategy. So push-pull strategy is a more targeted resource where we push plants, or so we use like a push plant or queue to push the pest away, but then you also have another resource that will pull them, will attract them and grow into a different area that is not your cash crop. in this project, we are testing different volatile compounds from red clover and from entomopathogenic fungi to see what are the effects on the main pests during the autumn of algae rape, which are cabbage and flea beetle and slugs. So Suleiman, which is developing this work, is currently looking at the olfactory responses of the grey-filled slug and cabbage and flea beetle to a combination of treatments. Between these are like damage algae rape by conspecifics. So are cabbage and flea beetle attracted to plants that have already been damaged by cabbage and flea beetle or slugs. Also about red clover and the companion crops, how that affects the attraction for cabbage and flea beetle, and looking at Methadicium bruneum, a entomopathogenic fungi, how it affects the attraction on cabbage and flea beetle and slugs. And then getting into breeding for resistance to cabbage and flea beetle, when we started, well, there is no insect-resistant cultivars available for any algae rape pest. We started this project 3 years ago now, together with John in a center, so Rachel Wells and Ryan from JIT and Sam Cook at Rothamsted Research. In this project, we wanted to explore the genetic diversity of 20 different varieties from different breeders, see if there was any difference between these varieties in the field, in feeding damage and larval numbers. So we assessed cotyledons during autumn, and we found that most of them were, first of all, this was a huge effort. We collected all the cotyledons, scanned them, and used ImageJ, which is an image software, to count the number of holes and just to assess the feeding damage. And we saw some significant differences between the algae rape lines. So you can see some that are that have been less fed on. We still don't know why, which is our next question, if they are less palatable, less attractive for some reason, but there is a significant difference that we will explore further. Then regarding the larval antibiosis, so we collected plants from the field, as we normally do, to count the number of larvae. Instead of dissecting them, we just put them in trays and let them dry. So the cabbage and flea beetle larvae goes out of the plant, and then it's more easy to collect them and count. So yeah, under the microscope, we counted thousands of larvae, and the results were not that great. So we found some significant differences in larval numbers across lines. We did this once a month. Sorry, I forgot to mention that. So to see if that difference between lines was consistent across time. And although we found some differences in the number of larvae between lines, these differences were not consistent through time. However, we found that the grain yield, so the final yield of there was a significant difference in the grain yield between the different lines. So if you consider that there were no differences between the number of larvae between lines, but there were some lines that were performing better at the end of the season, we can see that those lines have the potential to be more tolerant and grow away better from cabbage and flea beetle than the others. This project is going to finish in November this year. So by then we will write a proper report, and hopefully we will be able to disclose which of these. These are all commercial lines, by the way. So yeah, this will be available at some point at the end of this year. As I was telling, it's a lot of, and most of you know, is a lot of work to detect the the number of flea beetles, like the flea beetle pressure. So one of our projects is looking at automatic detection of both the adult damage and the larvae. So one of the projects is developing image processing and image learning tools to identify and quantify the adult cabbage and flea beetle feeding damage. So hopefully in a few years we will be able to get our smartphone out, get a picture of the cotyledons, and it will tell you the damage, the percentage of damage that you have in your field. And also we are using some acoustic detection to detect the larvae that is feeding inside the plant. So instead of dissecting or waiting for the larvae to go out, you can just clip on these contact microphones and it will record the larvae feeding inside. So we are still testing that in the lab, as you can see in the picture, but it's giving really good results. So stay tuned, because hopefully in a few years, 3-4 years, we will have these devices up and running. And then we arrive into my favorite part of the talk, which is the natural enemies. So I mainly work on this. This is Microturnus brassicae, which is the parasitoid of the adult life stage of the cabbage and flea beetle. You can see that's the female inserting the ovipositor through the body of the cabbage and flea beetle. They lay eggs inside. These eggs develop, eats the beetle from the inside and kills them. So they have a great potential to control this pest. In captivity is up to 75%. And we don't know much about this parasitoid. If you go to the literature or if you ask around, there's nothing. There's just 2 papers talking about this parasitoid. But there are a lot of gaps in phenology, prevalence, or how this landscape diversification that I was talking previously about is affecting the populations. So, yes. So we've been studying the parasitation rate. Maybe some of the people in the call have sent me beetles in the past years to assess for parasitation and resistance. And this is what we've found. So we started with a pretty low parasitation rate of just 7%, but it was present in almost most of the fields, like 70%. And this has been growing through the years. And in 2021 and 2023, it was present almost in all the fields with a varying parasitation rate. But it achieved a maximum parasitation rate of 36%, which is, it's a percentage where you can start to know that it's controlling a bit the population. Obviously, parasitoids will never kill all the beetles present, but it will give a significant control to reduce the populations to manageable levels, let's say. And just to finish with, if you remember the IPM pyramid, the last resource is synthetic insecticides. And we are also working on that. So we are working on organic synergists. So these synergists basically block the detoxification enzymes, which break down the insecticidal molecules inside the beetles. So we've been testing these organic synergists together with pyrethroids. See how well we've tested in the lab, but also in semi-field experiments. We still need to go into the field, but we've seen really, sorry, I thought there was another slide. Sorry, we've seen really, really promising results. It works really well. It brings back pyrethroid effects, and it's even if you mix the synergist with just 20% the field rate of the pyrethroids, it kills 90% of the beetles, much more than using 100% field rate of pyrethroids on its own. And that work will be out soon. And we are working with a press labs to see how can we take this forward for commercialization, basically. And just to finish off, I wanted to talk about this possible collaboration. So there's a full adopt grant out there, which is farmer-led, with collaboration with some academic institutions, research organizations. So I've put some details there. It will start by the 1st of November of this year. So if any of you want to collaborate, if you have any ideas, we are more focused into habitat diversification now, intercropping, undersowing, and field margins. Will be great to test this in any of your fields. But anyway, any other new ideas, projects, just feel free to drop me an email if you want to collaborate. And yeah, we are open to anything. And that's me. I hope you enjoyed. Thank you very much.
Lovely. Thank you very much, Patricia. Thank you for your input. Really interesting stuff. I was particularly interested in the trials of companion planting, and be interested to see how you progress with the habitat diversification and that push-pull strategy as well. Let's go to Ben then first. So, Ben, you discussed earlier about your experience with growing oilseed rape. So let's delve deeper into that and find out how you use IPM in your system. So maybe start with the establishment. How do you make up your mind on the timing of drilling, perhaps?
Yeah, it's a good question, because there's probably two schools of thought. There's those in the camp of early drilling because they want to get a crop established in good time and get a big crop of rape heading into the winter. And they think with the early drilling, it'll withstand the adult attack better than late drilled. But then there's a school of thought around later drilling, because you pass that peak migration of flea beetle. But the danger there is drilling later is if the weather turns, getting decent establishment ahead of winter. So for me, we've switched to sort of later drilling, purely because we've tried earlier drilling, which can work in some situations, but I feel like it adds to disease pressure with early drilling. And I think we get more larvae in the stems because it has more, the adult flea has more time to lay eggs, so there's more pressure there. So switch to sort of start drilling early September. Soil moisture is critical to establishment. It's about, we sort of drill it with a precision drill, so every seed is placed, and give it the best chance to establish as quickly as it can to get away from pest pressure. So moisture is critical, consolidation, good seed bed is critical to that establishment. We're also using starter fertilizer to aid in establishment, using DAP. And we're also fortunate because we've got our own on-farm produced digestate with anaerobic digestion we have, that we can also use liquid digestate, which I think probably just deters flea beetle for a few days as well. Just whether it's a smell, just puts them off. But so that aids establishment. Yeah, I'm not going to pretend it's easy to grow oilseed rape. For me, it's a bit of a jigsaw, and it's trying to piece everything together as best as you can to give yourself the best chance to grow a crop. It's not easy, and it's trying to get everything lined up, all the cultural controls in place. Things like leaving the stubble longer to deter the flea beetle. It also helps keep the pigeons off a bit as well. Also helps keep chop straw keeping moisture in as well, which will help. So yeah, it's reducing soil movement. So we're sort of we've got like a strip till system direct into stubble. So we're only moving a very small amount of soil, which again helps conserve moisture. And helps that sort of the flea beetle seeing. If you cultivate all the soil, they see the green plants against a brown background very easily. That sort of whereas within the stubble, it's sort of don't spot it quite as easily. So I think that helps a bit as well. So yeah, that's
moisture at the beginning. Obviously, this spring has been exceptionally dry for all of us, and we're all struggling perhaps to establish our crops. How difficult or otherwise has it been for your oilseed rape?
This year, it's been it was okay. I think the early drillers got really good establishment this year, and didn't seem to be the flea beetle pressure around this last summer. So that's if somebody can predict the levels of flea beetle, it will be a massive help to me as a farmer and grower. That if you could predict that, it was always August bank holiday weekend was like that's when you're going to see the big migration. So it was.
I can't predict that, but I know that Limagrain have come up with this characteristic, the cabbage stem flea beetle resilience, which I know that you use. Talk us through that and how that might have helped.
Yeah, definitely. I think genetics is a big help to me as an agronomist for various reasons, and we're trying to sort of reduce inputs, maximize outputs, and having that resilience in the variety against cabbage stem flea beetle is really important. It could be the difference between a good crop or a failed crop. So it's really keen to explore that. We've grown algae Avenger, which has that trait this year. It's looking really well. It got drilled quite late, sort of mid-September. It had really good autumn vigor. Really good going into the winter. Didn't seem to have any pressure from flea beetle. So really pleased with how it looks. So certainly variety, I'll be considering to take a large amount of my area going forward. It's not just the sort of that resilience to flea beetle, which is great, but it's got a great genetic package, which is what we look for in choosing varieties.
You grow about 1,000 hectares in total of oilseed rape, don't you? Significant acreage.
Yeah, it's significant. It's still see it as a significant break crop for us. We're quite fortunate we've got some other break crops, but it is a good break crop. It spreads the harvest workload with sort of the earlier harvest and earlier drilling. And we've sort of reduced the area a little bit from the heights. Some of that is around rotation with sort of 1 in 4 minimum, but I know ideally we're sort of 1 in 5, and I think that helps with crop performance. Where we've sort of grown 1 in 3, we've certainly seen probably 0.5 ton a hectare yield reduction from that tighter rotation, which is probably verticillium. So I think the 1 in 5, it just helps with stem health. Also reduces the pest pressure as well for the crop in that longer rotation. So I think that's crucial cultural control for myself growing oilseed rape is that longer rotation.
Yeah, great.
So I'm going to talk a bit about how oilseed rape genetics help IPM on farm. In terms of our oilseed rape breeding program, we have always been at the forefront of winter oilseed rape breeding. We have a UK dedicated program, and we've introduced throughout the years new varieties, new traits and characteristics, which have continuously improved yields and also disease resistance. Now, what we're doing now is our current breeding program has undergone a complete shift of approach when it comes to conventional breeding. So we're now looking at producing hybrid varieties that are adapted and consistent across various climate events, disease pressures, and also the cabbage stem flea beetle threat. And as I said, we've introduced a lot of traits and characteristics. So if we look back on the timeline, only in 2006, we've introduced the first hybrids were introduced. Now in 2008, we've introduced resistance to foam stem canker. Then in 2010, pod shatter resistance, 2012, club root resistance, 2014 resistance to turnip yellow virus technology with the herbicide. Turnip yellow virus is a virus transmitted by aphids. Now infections can occur in both autumn and spring, and normally when the conditions are mild and warm. Symptoms of the virus cannot normally be seen in the spring, and they're often mistaken for stress or nutrient deficiency. So what we get with a plant that's infected with turnip yellow virus is we get stunted plants, we get a purple curling of the leaf margins, and then you get reduced branching, fewer seeds per pod, and reduced oil content. And in some instances, you can get a yield reduction up to 30%. Now, once the virus has taken a hold in the plant, it cannot be controlled. You can't spray for it. You can't really do anything about it. So the only sort of thing you can do is you can grow a turnip yellow virus resistant variety. So you can maximize yield potential, and obviously turnip yellow virus genetics are the cornerstone of IPM strategy. Now, pod shatter resistors. What is pod shatter? So pod shatter is a natural process that enables seed dispersion. So once they reach maturity, those pods, they just want to break and spread the seed all over. Now, the pod shatter resistance trait was introduced into oilseed rape together with a restorer gene from radishes. Now, obviously, if you've got a variety that doesn't have pod shatter resistors, it can drop the seed, and obviously that can result in quite high yield loss. So why is pod shatter important? So when you get the oilseed rape plant, you get degrees of ripening on the plant. So the top pods are overripe, and then as you go further down through the crop canopy, you've got mature seeds, and then seeds that are close to maturity, and then some seeds that are still green. So what we think it's important to have pod shatter resistors, because you can wait for optimal seed maturity and cut your oilseed rape when it's all ripened and matured, and then you can maximize yield.
Some of our viewers have already been sending in questions, but anyone can answer perhaps these questions, but maybe I can start with one of my own. How much does autumn nitrogen application increase the success of oilseed rape establishments? Can you put a percentage on that, perhaps, Patricia? I don't know if that's your field of expertise, or maybe Ben has had some autumn nitrogen application experience.
Yeah, I can take that. I think it's hard to put a percentage on successful or not. It's something I've been doing for a long time. As I said, starter fert with placing DAP with the drill. I think it just helps establishment, and that is the successful. To be successful with oilseed rape, it's all about establishment. Is critical. So anything that you can do to help establishment, and definitely with autumn N. Yeah, I think starter fertilizer, place fertilizer is crucial to that. It's getting that good crop established ahead of sort of winter and pigeons, etc. That is crucial.
Oh, it's good to hear about your experiences in growing such a big acreage as well. And our viewers have submitted some questions too. Do you think oilseed rape has a future in the UK, or will the declining acreage we've seen in recent years result perhaps in a permanent reduction in capacity at our crushing plants?
I think a lot of it will be the economics. The price will have a big effect. When rape was £700 a tonne, everyone was having a go, but when it's down at 300, it's sort of less attractive. I think the crushers, potentially, there maybe has been a lack of investment in crushers in the UK, but they will import oilseed rape from all over the world. They would literally just buy the cheapest oilseed rape and use that. So there's big facility at Erith, which is going to carry on, I'm sure. But for me, I think it's also being able to UK provenance, having UK produced rapeseed oil is crucial for us. You look at some of the sustainability challenges around olive oil, and how that's it's not gone very well. And you looked at Russia and Ukraine and the challenges around sunflower oil. That actually having our own supply of UK rapeseed oil is critical for us, and hopefully something that we can carry on doing in the future.
Because I think you're based at Nocton. Where would your crop go for crushing? Which plant?
Majority of our oilseed rape will go down to Erith for crushing, but we are looking at our doing our own with a cold pressed rapeseed plant here at Nocton, and to produce our own oil going forward, which is quite exciting.
And I know you spoke about establishment at the beginning. How important is it from a disease management point of view that we get the establishment right?
Yeah, I think the key one obviously is verticillium. It's a little bit of an unknown. Some varieties have more of a tolerance to others, which you can look at. I think now that rotation is critical. It's just the foundations of good agronomy is rotation, and the longer the better. So I'd say would be, I prefer 1 in 5 to help with verticillium challenges. As I said, I've seen yield reductions from a tighter rotation. So yeah, I think variety helps, but rotation is where it's at for things like verticillium. Some of the other you've got some of the traits around FOMA, etc., which is useful to have as well. So it's that whole sort of traits package we look at into light leaf spot, stem canker, tolerance to verticillium. So they're all useful traits to have.
Okay, I think we'll pause questions there for a minute, and we'll give Florentina one more opportunity to see if we can continue with her presentation. Oh, looks like we've got that. So yes, we can.
And it was quite a good segue into it. I don't know if you've heard the last bit on pod chatter. I just want to make this point. So what I wanted to emphasize by showing you the picture of the machinery that applies force to splitting open the pods is that it takes quite a considerable force to split open pods from varieties that do have the pod shatter resistance trait. There is quite a significant force gap between the varieties that do have it and the varieties that don't. So there is no degree of pod shatter resistance. You either have it or you don't. And now, because Ben was so good at answering the questions about diseases, stem health. So why do we want clean stems? We want clean stems because having clean stems means we're going to have very good seed fill, very good oil contents as well. So clean stems are the key to high yields and good oil contents. Now, stem health is an umbrella term that we give varieties that have good resistance to resistance and tolerances to 3 diseases. So former stem canker, light leaf spot, and verticillium. Now, for some of these diseases, there are chemical solutions available, but for verticillium, there is no chemical solution. So the best and most effective and sustainable solutions are disease resistances. Now, another disease that takes quite a bit away from oilseed rape is sclerotinia. So issues around sclerotinia are shown by white stems, white pods, and side branches. Now, when you get sclerotinia in a crop, you get increased lodging risk, reduced seed fill, and premature senescence, which can obviously lead to pod shatter and ultimately yield loss. For a 10% incidence of sclerotinia, you can lose up to 1.5 tons per hectare. Can you still hear me?
Yes, yeah, really good reception.
Okay. So scleroflex varieties have higher tolerance to sclerotinia, showing less incidence and less severity. And what I mean by less incidence and less severity. So if you look at this picture, incidence means how many plants are infected within your crop, and severity means out of the plants
It looks like I spoke too soon about the connection.
infected or low severity, and then it can take to lodging issues and less seed fill, and obviously reduce yield. So why is it important to have scleroflex in varieties? It's important for sclerotinia management. Now, quite a lot of farmers listening to this know how hard it is to hit that 65 growth stage when it is the perfect timing for applying fungicide against sclerotinia. Now, whilst fungicides are effective, they are effective if they are applied in time, because applying it after the perfect timing does not have they do not have a curative effect. So it's important in the sclerotinia management practice to have fungicide, to combine it with best farming practices. Obviously, timing is essential. And then if you can have a hybrid with sclerotinia tolerance, it can all help. Now, I'm getting on to probably what's most weighted characteristic, which is the cabbage stem flea beetle resilience. So what it is, it's a novel genetic approach that tackles cabbage stem flea beetle at key crop stages, but as part of an effective integrated pest management strategy on farm. Now, we all know that there is quite a high pressure and challenges on farm when it comes to cabbage stem flea beetle. We've got the increased pressure driven by climate change, the ban of neonicotinoid seed treatments. We've got less chemical available to tackle the flea beetle. And then we also have, as per Patricia's presentation, a lot of resistances to the chemistry already available. Now, the cabbage stem flea beetle, although it is one pest, it does have two crucial periods for damage. So you first get the adult damage. The adults come in, they start feeding on the cotyledons and the first leaves. Then they lay eggs, and then the larvae start growing and eating. They mine petioles, they leave petiole scars in the stems. And then the symptoms of cabbage stem flea beetle attack, we all know them. You've got the shot holing damage caused by the adult feeding, and then you've got the larvae in the petioles and in the main stem, causing stunted bushy plant symptoms. Now, what can we do to approach IPM in terms of cabbage stem flea beetle? So we need to look at crop establishment. We need to give the crop the possibility to establish and grow away from the adult feeding. So lower quantities of residues from the previous crop, adapted number of tillage passes, and adapted seedbed preparation. You have to wait for weather, for favorable weather and moisture. You have to drill it at the same sort of sowing depth, and then you need to roll it by case. You also need to adapt your sowing rates and be mindful of nutrient availability. You also have to look at the targeted insecticide application. So you have to monitor the adult populations, and you have to respect threshold applications. You obviously have to optimize your timing, because if you don't hit them, it doesn't work. And then use the recommended product and water volume to guarantee efficacy. Last but not least, you can use hybrids with cabbage stem flea beetle resilience. So these sort of hybrids use a sort of an escape mechanism to achieve the high yield potential. Now, what it is these sort of hybrids have a series of characteristics that make up the cabbage stem flea beetle resilience. So they've got autumn dynamic growth, good spring stem elongation. They've got a reduced number of cabbage stem flea beetle larvae and reduced damage severity because of the larvae. So you've got less stunted bushy plants. Now, how and why does that happen? So for the first one, for the strong autumn vigor, strong autumn dynamic growth, it's key to higher resilience. So they sort of escape the damage by the cabbage stem flea beetle adult. The spring stem elongation, so the fast development after winter, leads to improved plant robustness and higher resilience to the larvae. Now, in terms of the number of cabbage stem flea beetle larvae, these varieties have a capacity to limit the number of larvae developed in the stems, and we assess this by doing Berle's test to count the larvae. And then last but not least, even though they've got quite a lot of larvae in them, these varieties show less symptoms of larvae damage, so less stunted bushy plants. And just because I am quite a visual person, and I think a lot of farmers might be as well, you can see for autumn dynamic growth in the top left-hand side corner, we've got two varieties that are at the same growth stage. They're both between the 4 and 7 true leaves, but obviously one of them got there a lot quicker. Spring stem elongation, they're all starting at the same sort of time. They all start flowering at the same time homogeneously. And then we also assess the number of larvae. You can see how many Berle's tests we do to actually count the larvae. And we also look at the larvae damage severity. So you can see in the bottom right-hand side corner a crop that has quite a lot of stunted bushy plants because of the larvae damage. And then in the top right-hand side corner, a variety that, even though it has larvae in it, it's coped better and it flowers evenly. Now, although this is a first step into mitigating risk from cabbage stem flea beetle, it doesn't work on its own. It's not a magic silver bullet. Not all of our problems are solved. So it needs to be used in conjunction with other IPM methods. So you need to monitor your thresholds. You need to plan according to them, apply insecticide, look at the weather, see if we're going to get some moisture, have a look at your seed beds and how you prepare them, all to guarantee good crop establishment. Now, you also have to evaluate effectiveness. So if you've done something and it's worked, have a look at why it's worked and try to replicate it for your own farm and for your own field conditions. Now, Limagrain genetics and our Limagrain hybrids, they're all fully loaded and fully invested. As a company, we are very confident in the future of winter oilseed rape in the UK. We are committed to this crop, and we do breed varieties that take into consideration all UK conditions and limiting factors to the success of the crop. And also our breeding program throughout the years has brought onto the market fully loaded varieties with strong and consistent on-farm performance. So I just wanted to take this opportunity to thank all the farmers that have trusted in our genetics and continue to use them. Thank you all.
Lovely. Thank you very much, Florentina. It was worth waiting for. Because you weren't here during the Q&A session we started earlier, I can see a question we've had in from Peter Collier that you might be able to answer. And he says that with the importance of verticillium and yield loss raised by Ben, is the lack of resistance in LG Avenger a cause for concern in high verticillium pressure regions, or LG Adapt a preferable option?
In terms of stem health, we do a multi-year evaluation on all of our hybrids. So we look at how much infection we get with verticillium and how well the hybrids withstand it. So if it's got the stem health badge, we consider it's got a good degree of tolerance to verticillium.
And another one that came in earlier, perhaps you're better placed to answer this. Our viewer says that he's been growing oilseed rape successfully for nearly 50 years In the 1980s, he was yielding 1.5 to 2 tons an acre. And he says that for years, he's been told that oilseed rape has the ability to yield between 4 and 5 tons to the acre. So he suggests that why is it that 40 or more years on, and he's still only managing 1.5 to 2 tons an acre?
Well, the genetic potential is there in all of our hybrids and all of our conventional varieties. The genetic potential for the oilseed rape to yield that much is there. Unfortunately, we've got a lot of diseases and a lot of pests and a lot of viruses that can rob from that yield potential. So what we can do is mitigate those sorts of risks by using varieties that have higher tolerances or resistances to those viruses, apply good farming practice. Also, it's dependent on the weather. So if you want to push for high yields, all of the tools are there. It's just how economically viable would it be to give it that push. So yes, in terms of the potential is there. It's just there's a lot of factors that can contribute to the limitations that we currently see in commercial crops out there.
And perhaps following on from that, should there be a new fertilization scheme going forward, perhaps?
Well, I think all farmers listening out there know what's best in their soils, and we can't really sort of give a fit-all solution to that. We need to look at our soils, our previous crops, what we've used before in terms of fertilizer, look at our rotations, see what the soil nitrogen supply is, see what the phosphate and the potash is in there, and obviously apply fertilizer according to your deficiencies. Yes.
I spoke to a farmer last week who was using farm-saved seed, and I can see that one of our viewers is asking to cut costs. Should we use farm-saved seed?
I think each farmer can sort of look at their cost and make the best decision, but you need to be mindful that all of these genetic traits and characteristics, they come with hybrids, and you can't home save seed out of hybrids.
Okay. And are there benefits from sowing seed at a higher density?
I can answer, I think,
Yeah,
if you want. No, for me, no. I think if you have a too thick a crop, you end up with very thin, wispy stems. So if you get larvae in those, it's game over. So whereas lower, I know it's not easy to say lower population, because obviously trying to get a reasonable establishment, but obviously with a lower population, you get bigger, stronger plants that are branched out. So yeah, population is critical to yield, and yeah, it's important to get that right. But yeah, if you don't, too thick is potentially problems around larvae and yield as well.
Yes.
Yeah, sorry,
I got halfway through that. So yes, I can definitely sort of attest to what Ben just said. Yes, it is a fine balance, because you want plenty of plants established, and obviously when you've got cabbage stem flea, beetle, or dolt attack the young seedlings, you want them to be more of them there so that they don't take out everything. But as Ben said, the higher the population of oilseed rape plants per square meter, you end up with thinner stems, and with thinner stems you get more larvae damage, and then there's more entryways for diseases, and those diseases can cause lodging and ultimately yield reduction. So yes, it is a fine balance, but yeah.
Okay. Well, I think we'll end on that question, but thank you very much, everybody, for your time this evening, to our viewers, and to Florentina, Patricia and Ben for your time and expertise. And I apologize for some of the technical issues that we had during that broadcast, but hopefully you gained a lot from that. And I hope that the time you've invested in this webinar has left you with a greater understanding of the topic, and that it's helped with the decision making that you'll make on how to proceed within your own businesses. So on behalf of the panelists and myself, a huge thank you to you all for joining us, and good evening.
Thank you, Debbie. Thank you.